Let's look at proofs involving parallel lines, example number 2. I've drawn the figure over here, so draw that in your notes nice and neat and make sure you label it properly. We are given that ray AB bisects angle CAD, so ray AB bisects angle CAD, and CB, line CB, is parallel to line AD. We're asked to prove that angle 1 is congruent to angle 2. So I've set up my 2-column proof, but first I'm going to work on my figure and see where all this information leads me to prove that 1 is congruent to 2. So given that ray AB bisects angle CAD, what would that tell me? So if this ray bisects this angle, then I know that angle 2 would be congruent to angle 3. So that helps me out. I'm trying to prove angle 1 is congruent to angle 2. And if I know these two lines are parallel, then I know that angle 3 and angle 1 are alternate interior angles to one another. So therefore, we could say that if 2 is congruent to 3, 3 is congruent to 1, then 1 must be congruent to 2 by the transitive property. So now we just need to map all that out in our formal 2-column proof. So for number 1, I'm going to put that first given statement, ray AB bisects angle CAD, and my reason, of course, is that it was just given to me. Then I'm going to put the next thing is what that told me. So after that first given statement, I'm going to go ahead and put that since that ray bisected that angle, I now can state angle 2 would be congruent to angle 3 because of angle, we say definition of angle bisector. That's the way we want to write this. So let's put definition of angle bisector. And then the next thing we noticed is because these lines were parallel, but we were given that they were parallel, so we need to state that. So let's put that next. Number 3, we were given that CB, line CB was parallel to line AD. We didn't just assume that. That had to be given. So we can put that next. And what that told us was that angle 3 would be congruent to angle 1. So let's put that next. So angle 3 would therefore be congruent to angle 1. And the reason is those are alternate interior angles, and those are always congruent when we know that those lines are parallel. And then we can state our proof statement. We always know this comes last, the thing we are proving. So angle 1 is now congruent to angle 2 because angle 2 is congruent to angle 3. Angle 3 is congruent to angle 1. So therefore, angle 1 is congruent to angle 2 by the transitive property. And we can abbreviate a little bit when we're writing our proofs. So let's look at the flow proof and the paragraph proof forms of this same proof. I like to work through the 2-column proof with you because it's the most formal and this is the most commonly used form. But there are 2 more forms that we could use to write it. So like we saw in example 1, the flow proof uses the same information and usually it flows well with what you are given, what it tells you, and how you prove what you need to prove. So we were given that ray AB bisects angle CAD. Knowing that, we were able to go to angle 2 is congruent to angle 3 because of definition of angle bisector. Given that line CB is parallel to line AD, we could conclude that angle 3 was congruent to angle 1. So those 2 things, that comes from that one, so they are connected. And that's because of alternate interior angles are always congruent. Then these 2 statements help us to come together at the end and say angle 1 is congruent to angle 2 by the transitive property. So then I've written it out in a paragraph form. This is the least formal type, like we talked about in example 1, but still another form of a proof. We could say it is given that ray AB bisects angle CAD and line CB is parallel to AD. It was given. By definition of angle bisector, angle 2 is congruent to angle 3. Using alternate interior angles are congruent. Angle 3 is congruent to angle 1. And then last but not least, we can say that by the transitive property, we can conclude that angle 1 would be congruent to angle 2.